is about composition of functions. And a composition of functions is just one function within another. It's a function inside a function. Okay, a function inside a function. So you did this in Algebra 1 and Algebra 2 for sure. Okay, a function within a function. We have f of x equaling 5x minus 1. Then we have g of x equaling x plus 1. We're looking for f of g of 2. Anybody tell me what that first step is? Yes, that first step would be to do the inside, do g of 2. Okay, so to do g of 2, that 2 is the x value in the g function. So instead of x plus 1, we're going to call that 2 plus 1. So g of 2 is 3. G of 2 is equal to 3. Okay, now we found g of 2. Okay, so our function is now f of the answer from g of 2. So it's now f of 3. Okay, so the f function is 5 times x minus 1. We'll put the 3 in place of that x. So 15 minus 1 is 14. So 14 here is our final answer. We put one function inside another. So we solve for the inside value first, then replace the inside with that value and go from there. Okay? So the same process works for compositions of trig functions. We'll have a trig function within a trig function. Okay, another little quick piece of review. If we have a trig function of something equaling an answer. Okay, if we start with the trig function, then what goes inside the trig function? Is it an angle or is it a ratio? We start with a regular trig function. Is the interior of that an angle or a ratio? Just think sine. If we take sine of something, is that something an angle measure or a ratio? Yes, y'all have got it. Good. That's an angle measure. So then the answer is it's got to be the other one. Ratio. Good job, y'all. Okay. Now, if we have an inverse trig function, we take the inverse trig function of a what? Is it a ratio or an angle if we have a trig inverse? That is a ratio. And then that's equal to the angle. Okay? So we'll work the inside first. Okay? We'll work the inside of these functions first. So in example 1, cosecant inverse of tangent of 3 pi over 4, we'll work that interior piece first. Okay, so move spot for that final answer. Let's go right there. So we'll do the interior first. We will do tangent of 3 pi over 4. Is 3 pi over 4 an angle or a ratio? 3 pi over 4. Is that an angle or a ratio? It is an angle. Okay, so then the answer we get will be the ratio. Okay? So we want tangent of 3 pi over 4. Since 3 pi over 4 is the angle, draw the angle. Okay? Label your axis 0. We have a denominator of 4. So label that left as 4 pi over 4. Then straight up is 2 pi over 4. Down would be counting by 2 pi. 6 pi over 4, equivalent to 8 pi over 4. So in what quadrant is 3 pi over 4? In what quadrant is 3 pi over 4? It is in quadrant 2. Okay, we'll draw our angle from 0, 0, drop a perpendicular to the x-axis. One leg sits on the x-axis. Theta is in the corner at 0, 0. Y'all heard that speech before? Hopefully it's as memorized in your head as it is in mine. Okay, now, what is our reference angle? Or what kind of triangle is this? It's going to have to be a 30, 60, 90 or a 45, 45, 90. It'll be one of the two unless it's on an axis. So which type triangle is this? It's a denominator of 4, so it's going to be that 45. Yes. Any denominator of 4 is going to be that 45, 45, 90 triangle. Okay? So when we label that 45, 45, 90 triangle, okay, cross from each 45 is root 2 over 2. Hypotenuse is 1. Do we need any negative signs here? Where? On the y or on the x? Yes. The x goes left, so that is going to be a negative square root 2 over 2. Okay? Now, to do tangent, okay, you can think opposite over adjacent. You can think y over x. Okay? That y and that x are the same number, but with just different signs, correct? Okay, so we'll have a plus over a minus, positive root 2 over 2 over negative root 2 over 2. So what is tangent of 3 pi over 4? What is tangent of 3 pi over 4? Give me a number. This will be a nice number. This one's actually not a fraction or a decimal or anything. What is tangent of 3 pi over 4? What's any number divided by itself? Okay, we've got a negative sign here. So this is, yes, negative 1. Tangent of 3 pi over 4 is negative 1. Good job, y'all. Yes. Okay. Now, we're not done yet. Okay. We found tangent of 3 pi over 4. The question wanted cosecant inverse of tangent of 3 pi over 4. Well, now that we've got that inner part of negative 1, we can find the rest of this. Okay, so we have cosecant inverse of the answer we got for tangent 3 pi over 4. So now we have cosecant inverse of negative 1 equal to, and that'll end up being our final answer once I find it again. Okay. Okay, so cosecant inverse of negative 1. Is that negative 1 a ratio or an angle? It's a cosecant inverse. So yes, that is a ratio, which means our answer will be the angle measure. Okay, cosecant is 1 over sine. Okay, cosecant is 1 over sine. So it's 1 over y. 1 over y is 1 over -1 here. Good? Okay, so drawing our axis, where is that? Where is the y value -1? Where is the y value going to be -1? It is on an axis. Yes, you are correct. It is on an axis. Where is the y value? -1. Okay, yes, it is down. Okay, this is where y value would be -1. Okay, now, at what angle is that? Ooh, I've got 2 really good answers. I've got 2 really good answers. Okay, I've got a 3 pi over 2, and I've got a negative pi over 2. Which one of those do we use? We use negative pi over 2. Okay. Remember cosecant inverse. We need to remember those principal inverse values. Okay. Cosecant inverse can be in quadrant 1 or quadrant 4. Okay. This ends up on the y-axis. Not really in either quadrant. Ends up on the negative y-axis. Okay. Remember the range for cosecant inverse is negative pi over 2 to pi over 2. So we need to call that angle negative pi over 2, not 3 pi over 2. That ties back to what we did last lesson in 10.1. Good? Okay. Our final answer here is that angle we found, negative pi over 2. This is the final answer. Okay? Do one step at a time. Okay? Do one step at a time. Questions on this one? All right, let's take a look at example 2. Okay, and let's reason through this. Okay, we have sine inverse of cosine of pi over 6. Okay, so this inside answer to cosine pi over 6. Okay, we have cosine of pi over 6. Is pi over 6 an angle or a ratio? It's cosine. Okay, so it is pi over 6. Okay, that's an angle. So then that answer to that interior would be a ratio. The answer to that interior would be a ratio. Okay, then the final answer would be an angle. Okay, we start with an angle. Okay, we start with an angle. We use the interior inside function to find the ratio. Then we plug that ratio into the outer function and we find the angle. Okay? So, okay, to find cosine of pi over 6, draw the triangle. Where's pi over 6? It's quadrant 1. Yes. Yes. Okay. Pi over 6 is quadrant 1. Okay, what's that? What type of triangle is that? It is a 30, 60, 90. What is that reference angle? It is 30 degrees. Good. So across from the 30, we label a 1/2. Good. Across from the 60, ooh, it's not 3/2, but we're close. That is root 3/2. And then the hypotenuse is 1. Okay. Do we need any negatives here? No. Good job. Okay. So we are looking for cosine pi over 6. Okay. Cosine is x, y, or a fraction of those. It is the x. So cosine of pi over 6 is our x, root 3/2. Okay. All right, now that is not our final answer. Okay, that is not our final answer. That cosine pi over 6 was the angle. We found the ratio, root 3/2. Okay, now we need to do the second piece, sine inverse of that root 3/2. Sine inverse of root 3/2. Pardon me. And this will be our final answer. Okay. So sine inverse of root 3/2. That root 3/2 is the ratio. Our final answer here will be an angle. Okay. So the sine inverse can be in what quadrants? Principal value for sine inverse, it's a 1 or a 4. Okay, so root 3/2, sine is the y value. So we would want the y value to be that positive root 3/2. That means it will go in quadrant 1. Yes, good. Okay, so our root 3/2 is the y value in quadrant 1. Okay, what kind of triangle is that? Okay, it is a 30, 60, 90. Okay, what is that reference angle? What is that theta? It's across from a root 3/2, so it would be 60 degrees. Okay, now we started in radians with that pi over 6, so we need to keep that in radians. What is 60 degrees in radians in quadrant 1? Yes, pi over something is correct. Yes, pi over something is correct. What is that something? Pi over what? 60 degrees, so it is pi over 30. Okay, yes, that x would be the 1/2, and that hypotenuse would be the 1. Yes. Okay, how we doing here? Yes, these will be 2 parts. Okay, these will be 2 parts. So we haven't quite gotten that far yet, but sometimes we'll need 2 triangles, sometimes we won't. Okay, we're going to do a few more, and then we're going to see if we can put it together when which happens. We're going to answer that question, I promise, just not right now. I promise. Y'all trust me. Good? Okay, so let's look at 3. Okay, look at 3. No, I really wanted to look at that. So we have cosine of cotangent inverse of -1. So if we start with the inside, cotangent inverse of -1 is that -1, an angle or a ratio? It's inside a cotangent inverse. So yes, it is a ratio. So that means the inside answer would be an angle. Good. Okay. Then that final answer would be a ratio. Yes. Okay. Good. All right. So let's look at this. Okay. First step would be cotangent inverse of -1. Okay. Cotangent theta, is it x, is it y, or is it a fraction of those? It is one of the fractions. Which way? Yes, x over y. Okay, so cotangent inverse of -1, that x over y would be -1 over 1. Okay, now what quadrant can cotangent inverse fall? In what quadrants can cotangent inverse fall? Cotangent is like a cot, a little portable bed. Okay, there's your little pillow. So then we are looking in quadrants 1 or 2. So if we can stay in quadrants 1 or 2 only, where's the negative? Is it going to be on the x or on the y? The fraction, the way it's written, looks like it's on the negative. It looks like it's on the y, I'm sorry. But realize this, I can put that -1 on the y, and it's still equivalent to a -1. Okay, but for quadrants 1 and 2, yes, the only thing that could be negative in quadrants 1 or 2 is the x value. Okay, so we'll have an x, I know. Sorry. We will have an x that's negative. We'll have a y that's positive. And those are the same value. Okay, so that x is going to be a -1, that y is going to be a +1, but those aren't normal values we use for triangles, correct? Okay, think about which kind of triangle has the x and the y the same, and we figure out this is a 45, 45, 90. So if we do square root 2 over 2, negative square root 2 over 2, that hypotenuse is 1, like we usually do it. Okay, are we good? Okay, so that -1, again, was the ratio. So our answer to this piece will be the angle. Okay, that is a 45, 45, 90 triangle. So it is a pi over 4 reference angle. But that's the reference angle. Think 4 pi over 4 on the right. Okay, go backwards by that reference angle. And this is at 3 pi over 4. So cotangent inverse of -1 is 3 pi over 4. Questions here? Now, that was just the inner function. We need the outer function. Okay, we need the outer function. So we need cosine of the result we just got. Well, that result we just got was 3 pi over 4. Okay. Now, do we need another triangle here? No, we don't. Okay? We started with a ratio being given to us. We used one triangle to find that angle. Then we need to use that same angle to find the outer ratio. So we already have a triangle drawn with cosine, well, with 3 pi over 4. The triangle's already right there. So we don't need another triangle here. You draw one if you wanted to. It's going to look just the same as the one we have over here on the left. Okay? So cosine 3 pi over 4. Okay, cosine 3 pi over 4. Cosine is the x value. So what is our x value here? Don't forget that negative. Negative root 2 over 2 is the x value. Okay, so cosine 3 pi over 4, yeah, that's okay, is the negative square root 2 over 2. So what that tells us is that cosine of cotangent inverse of negative 1 is that negative square root 2 over 2. Final answer. I can't. It's going to have to be a little. Okay? How are we doing here? There are quite a few steps. Yes, there are. Okay, there are definitely quite a few steps. You've done them all before, though. You've done all of these steps before. We're just putting a couple pieces of them together. Okay? All right, let's look at example 4. What part of this do we do first? The inside, yes. Okay, cosecant inverse. Cosecant inverse of negative root 3 over 3. Okay, that negative 2 root 3 all over 3. Okay, what is that, an angle or is that a ratio? Okay, that is our ratio. Okay, so we're starting with the ratio, meaning when we do cosecant inverse, okay, of negative 2 root 3 over 3. Okay, we'll have a ratio. And then the answer to that will be an angle. Okay, so let's think about cosecant. Cosecant is 1 over sine. Okay, so that 1 over y would equal negative 2 root 3 over 3. Okay, now that number looks a little weird. Okay, that number looks a little weird. What quadrants can cosecant inverse fall in? It is 1 and 4. Okay, and we've got a negative situation here. Okay, we've got a negative situation here. So we will be in quadrant 4. So we will draw that triangle in quadrant 4. Okay, now, this one looks a little weird. Okay, this one looks a little weird. However, we can get it there. Okay, we can get it there. The if we think of cosecant as r over y, okay, if we think of that as r over y, that radius would be -2 root 3. Now, we usually want the radius to be a 1. Okay, so to get that radius to 1, we divide by 2 root 3. Meaning to get that y value, it's 3. We take that 3 and divide it by -2 root 3. Okay, now we can't leave that root 3 in the bottom. That's bad math. Okay, that's bad math. So we are going to do that process of rationalizing, okay, where we multiply by root 3 over 3. Okay, then that numerator is 3 root 3. There is a root on the bottom there. Okay, times -2 times root 3 gives us a 3. Okay, those 3's divided off, and that y value is -√3 over 2. Does that look a lot more normal now? It took a little bit to get there. Okay, it took a little bit to get there. Okay, we wanted the radius to be 1. So we divided by the r, -2 root 3. Once we did the rationalizing, that y was -√3 over 2. And that's one of those normal values. That x value would be the 1/2. And what kind of triangle is this? Yes, it is 30, 60, 90. And that -√3 over 2 is across from, it would be a 60. Yes, that reference angle. That reference angle is 60. And in radians, that is pi over 3. Yes. Okay. Now, to be in quadrants 1 or 4, we need to call this angle -pi over 3. Okay. It is 5 pi over 3, yes. But remember, we want those angle measures between -pi over 2 and +pi over 2. So we will use that negative angle measure. Okay. Now, we're not quite done yet. I know we already did a lot on this problem. I know. So we found cosecant inverse -2 root 3 over 3. Okay. Question wanted tangent of that value. Okay. So now we're finding tangent of -pi over 3. Okay. We already have the triangle. Okay. Tangent inverse. Okay. Tangent inverse, again, can fall in quadrants 1 and 4, which is good because we're in quadrant 4. Okay. Tangent is y over x. Tangent being y over x. Our y value is -√3 over 2. That x value is 1/2. Okay, remember to divide fractions. Leave the first one alone. Flip that second one, multiply it. Those 2's are going to divide out. Look for -√3. So tangent of -pi over 3 is -√3. So then tangent of cosecant inverse of -2 pi over 3 is negative square root 3. That is your final answer. Good. Okay, I want you right now to do example 5 and 6. Okay, I want you to try examples 5 and 6. You try these two. Okay, you try these two. We are going to break until 110. Do those two problems. Take a break in the next 10 minutes. Go. All right, guys, let's look at 5 and 6. On 5, we'll start with the inside, as always, sine inverse of negative 1/2. Because that's an inverse, that negative 1/2 is the ratio. And the answer for that part will be an angle. Sine inverse can be in quadrants 1 or 4. Okay, quadrants 1 or 4. It's a negative ratio, so that is going to fall in quadrant 4. Okay, sine is the y value. Make the illustrator. Sine is the y value, so that will be the negative 1/2. That'll make that x a root 3 over 2 and the hypotenuse a 1. So that angle measure across from a 1/2 is going to be in a 30, 60, 90 triangle. That reference angle is going to be 30, so pi over 6. So this angle will express as negative pi over 6. Okay, we'll express that angle as negative pi over 6. Then we'll do secant of that result, that negative pi over 6. Okay, we already have the triangle with pi over 6. We already have the triangle with pi over 6. So remember that secant is 1 over x. Okay, it's 1 over the x, 1 over cosine. So it's 1 over x. Our x is root 3 over 2. 1 over 3 root 2 is 2 over square root 3. Now, we can't leave that square root 3 in the denominator, so we have to rationalize it. So we will multiply. I hate it when I change the color and it's not an eraser. Multiply by root 3 over root 3. So then that's 2 root 3 on top over a 3 on bottom. So secant negative pi over 6 is 2 root 3 over 3. Okay, and that is the final answer. Secant of sine inverse of negative 1/2 equals 2 root 3 over 3. Okay, how are we doing here? All right, and let's look at 6. We have cotangent of secant inverse of 1. Secant inverse of 1 will be that inside piece. Secant inverse of 1. Okay, secant is 1 over cosine. So secant is 1 over x. So that 1 over x is 1, meaning that our x coordinate is 1. Okay. Secant inverse can be in quadrants 1 or 2. So where the x value is 1 in those quadrants, it's right here at 0. Okay. Where the x value is 1, on the x-axis we're at 1, that is at 0. So secant inverse of 1 is 0. Now it's a little harder to tell here, but because it was inside an inverse function, that 1 is the ratio, that 0 is the angle. And it's in radians, so I'm not going to put a degree symbol on it, but realize it is radians. Okay, now that's our first piece. Okay, we need to look at the second piece of this. So we need to find cotangent of 0. Cotangent of 0. That 0 is an angle. Okay, that 0 is an angle. So whatever it equals will be our ratio. Okay, so cotangent of 0, we already have the angle drawn. We don't need another triangle here. Okay, cotangent is 1 over tangent. Cotangent is x over y. So we'll want the coordinates for this point. The x was 1, that y is 0. Okay, so that x is, again, 1, y is 0. What's 1 divided by 0? It's not 0. It's not 1. Nope, nope, nope. Not 1, not 0. Quit giving me those answers. It's not 1. It's not 0. Sort of. Not real is not what we're looking for here. Okay, it is undefined. Yes. Okay, cannot divide by 0. So final answer to this question is undefined. Okay, here. All right. All right. There's some more examples here, and the worked out key that I will put on Classroom will have those. But that's all for notes unless y'all have any other questions today. Are we good? Okay.